morning, dear students, and welcome to our today's online class. We are studying about gases, one of the important and very interesting state of matter. In our previous class, we studied how these gases behave differently among other states of matter. We studied about their behavior and some important characteristic properties of gases in our earlier class. In our today's class, we are going to discuss about relationship of temperature, pressure, and volume of gases. So let us start our today's class. According to the kinetic model, particles of gases are always in constant random motion and therefore they possess kinetic energy. Let us discuss or try to understand this with the help of this diagram, simple diagram, where the pink circles indicate the particles of gases. I'm calling particle because the gases can exist in atomic form also, they can exist in molecule form also. Like gases like noble gases, helium, argon, they exist in atomic form. So we cannot always say that gases are in molecular state. Some gases like hydrogen, oxygen, nitrogen, carbon dioxide, water vapor, they exist in molecule form, but there are other gases also present in the air which exist in atomic form. Therefore, to understand gases, instead of saying molecules, it is better to use the word particles. Particles denotes both atoms as well as molecules. So according to the kinetic model, particles of gases are always in constant random motion, which is shown by the arrows of the particles. Now these particles move in all directions, and while doing so they collide with each other as well as with the walls of the container, which we discussed in our earlier class also. Now when the temperature is increased, if the temperature of this gas which is enclosed inside the container is increased, the kinetic energy of the molecules or the particles also increases, which thereby increases the molecular motion of the particles of gases. And when the temperature is decreased, the kinetic energy of the particles or molecules also decreases, as a result of which the molecular motion also decreases. So according to kinetic theory, the molecular motion is directly dependent on the temperature. It is directly proportional to the temperature. Hence we can conclude that the average kinetic energy of a particle is directly proportional to its absolute temperature, the temperature of the gas. More the temperature, more the kinetic energy. Lesser the temperature, lesser will be the kinetic energy. And more the kinetic energy, more will be the molecular motion. Lesser the kinetic energy, lesser will be the molecular motion. Now let us see what happens to the molecules or particles of gases when the temperature reaches 0 degrees Celsius. Now according to kinetic theory, when the temperature reaches 0 degrees Celsius, the molecules ceases to move. They do not move. This is according to kinetic theory. But in reality, these particles or molecules, they do not stop moving at 0 degrees Celsius. They continue to move. In fact, these molecules continue to move even at temperatures below 0 degrees Celsius. Therefore, the theoretical concept of molecules stop moving at 0 degrees Celsius does not apply in reality. Therefore, scientists, they believed that there is a need of another scale which really defines the kinetic theory of molecular motion of particles. Therefore, since molecular motion continues in negative temperature also, that is in minus temperature also, below 0 degrees Celsius also, now kinetic theory doesn't apply over here. So kinetic theory fails according to Celsius scale. Therefore, scientists came up with another scale, and that scale was known as Kelvin scale, or it is also called absolute scale. Now, according to this Kelvin scale or absolute scale, there is one particular minimum temperature which is known as absolute zero. Absolute zero, or which is also denoted as 0K. Please understand over here, we do not write degree for Kelvin. We only write K. Like for Celsius, we write degree Celsius. For Fahrenheit, we write degree Fahrenheit. But for Kelvin, we do not write degree. We simply write K, capital K. Therefore, the temperature which is absolute zero, and at this temperature, the molecules stops their motion. They stop moving. They completely cease, is known as absolute zero, and it is equivalent to minus 273 degrees Celsius. So absolute zero is a temperature equal to minus 273 degrees Celsius, at which the molecular motion completely ceases. This is a theoretical concept. Therefore, now, according to kinetic theory, now molecules stop moving at 0 Kelvin, which is absolute zero. Molecules do not stop moving at 0 degrees Celsius. Instead, molecules stop moving at 0 Kelvin, which is equivalent to minus 273 degrees Celsius. Therefore, 0 Kelvin is equal to minus 273 degrees Celsius. Now, therefore, the relation between Kelvin and degrees Celsius is Kelvin is equal to degrees Celsius plus 273. That means, in order to convert Celsius scale to Kelvin scale, we have to just add 273 to Celsius reading. Let us understand this by taking one example. Suppose the temperature in Celsius scale is 25 degrees Celsius. Now, if we want to convert this degree Celsius temperature in Kelvin scale, we need to use this formula, the relation of Kelvin and Celsius. Now, what is the Celsius value? It is 25. So, for 25 needs to be added to 273, which is equal to 298. Therefore, 25 degrees Celsius is equal to 298 Kelvin. So this is how we can convert Celsius scale to Kelvin. We can also convert Kelvin back to Celsius. How do we do that? We need to subtract whatever Kelvin temperature is given. From that Kelvin temperature, we need to subtract 273. So in that way, we can get, or we can convert Kelvin into Celsius scale. Now let us try to understand what happens to gases kept in closed container when they are heated. So we know that when gases are heated, their kinetic energy increases, and with more kinetic energy, they will start moving faster. So we know that molecules, they always collide with each other, and they also collide with the walls of the container. Now with heating, when we heat the gas, the temperature of the gas increases, they get heat energy, due to which their kinetic energy increases. Now with this increased kinetic energy, the particles of the gas starts moving more faster and strikes the wall more compared to the gas which is cool. Now the collision on the wall increases, as a result of which pressure exerted by the gas on the wall also increases. Hence, we can conclude that with the increase in temperature of a gas enclosed in a container, the pressure exerted by the gas also increases, and vice versa, which means with the decrease in temperature, the pressure exerted by the gas on the walls of the container also decreases. So we have to understand over here that with the increase in temperature, pressure of the gas increases, and with the decrease in temperature, the pressure of the gas also decreases. Now let us again now try to understand how volume of gas relates or increases with increasing temperature. Now let us try to understand this particular phenomenon with the help of this picture diagram. So over here we can see that there is a container, a closed container where there is gas, but the one wall of the container is made by movable piston. Now when the gas is heated, the kinetic energy of the gas particle increases, due to which the molecular motion increases, and with that increased molecular motion, the pressure on the walls also increases. Now when the wall is subjected to increased pressure, the wall which is made of piston, which is movable wall, it feels extra large pressure due to increase in temperature, due to which the increased molecular motion of the particles applies more pressure on the piston wall and increases pressure on the walls, and this pushes the movable wall. As a result, the wall gets pushed back, which is shown in another figure. Now this increased area inside the container also increases the volume of the gas. That means with the increase in temperature, the kinetic energy of the particle increases, due to which molecules moves even further, and hence the volume of the gas also increases. Therefore we can conclude that with the increase in temperature, volume of gas also increases, and with the decrease in temperature, the volume of the gas also decreases. Thus, the physical behavior of gases can be described by three standard variables, and they are volume, pressure, and temperature. With these three standard variables, we can define, or we can say, explain the behavior of gases, different gases. Now let us try to understand some standard units of volume, pressure, and temperature, because we are going to solve different numericals based on these variables. So let us try to see units of volume. The standard unit, SI unit of volume, is cubic meter, which is written as m to the power 3. Now, there are other units of volume also, such as milliliter, which is written as ml, cubic decimeter, dm to the power cube, and liter, L. 1 meter cube is equal to 1000 decimeter cube, which is equal to 1000 liters. 1 liter is equal to 1000 milliliter, which is also equivalent to 1000 centimeter cube. So I want you to learn these relation of different units of volume. In the same way, pressure, the SI unit of pressure is Pascal, but we use other units also to measure pressure, and the most common units are atmosphere, which is denoted as ATM, centimeter of mercury when mercury is used, and if the reading meter scale is in centimeter, then we say centimeter of mercury, Hg. If the reading scale is in millimeter, then we say millimeter of mercury. and the other unit of pressure is torr. Now, 1 atmosphere is equivalent to 76 centimeter of mercury or 760 millimeter of mercury, which is also equivalent to 760 torr. So 1 atmosphere is equal to 760 millimeter of mercury or 760 torr, and in centimeter scale it is 76 centimeter of mercury. So I want you to remember or learn this relation of different units of pressure also, so that we can solve numericals later. And finally, temperature. The temperature, the common scales are Celsius scale, degree Celsius, and Kelvin scale. So these are the two common units used for measuring temperature. But to solve numericals, we always prefer Kelvin scale to avoid the difficulty of 0 degree. Now we know that Kelvin, the relation between Kelvin and Celsius. Kelvin is equal to degree Celsius plus 273. So this is the unit which you have to remember for temperature. So I want you to remember or learn these units of volume, pressure and temperature, which are the standard variables and which defines the behavior or characteristic properties of gases. With this, we end our today's class, and there is an assignment number 10 for you. Define absolute zero. What happens to the particles of gases when their temperature is increased by heating? Number 3, what happens to the volume of the gas when the increase of pressure on the gas at constant temperature? It is actually what happens to the volume of the gas with the increase of pressure on the gas at constant temperature. And question number 4, convert the following temperatures. Number A, you have to convert 100 degrees Celsius to Kelvin, and number B, you have to convert 298 Kelvin to Celsius. So with this, we end our today's class. Until we meet in our next class, stay safe and do all things well.